Welcome to our new series where we look at some of the complexities of HCL and explore an easier solutions using Pulumi. We'll dive into real-life examples to showcase the differences between HCL and Pulumi, helping you appreciate the advantages of using a familiar programming language with Pulumi. Don't forget to check out our complete blog post at pulumi.com/blog. We'll start with the HCL example. Then, we'll switch over to Pulumi, where you'll see how we can leverage your favorite programming language skills to create infrastructure code that is easier to read and maintain. Let's dive in and simplify infrastructure code to make it as easy to write as possible. In today's episode, we're talking about the world of for-each loops. First, let's look at an HCL example featuring a for-each loop with a conditional statement. At first glance, it may seem straightforward, but we can immediately see the strict way a loop must be defined in HCL, as you must adhere to the strict format for implementing the conditional statements inside the loop structure. Additionally, you must also decide whether to use count or for each. This is adding to the complexity, as you need to know the difference between both to avoid unnecessary side effects. For example, count is sensible for any changes in list order. This means that if for some reason the order of the list is changed, Terraform will force replacement of all resources of which the index in the list has changed. This contrasts with how you would use these constructs in a generic programming language, where loops are more intuitive and flexible and offer more straightforward syntax and powerful control structures, making it easier to write, read, and maintain code. Now let's look at how we can approach the same example using Pulumi. Let's have a look at the TypeScript version first. The core of this code uses a chain of array methods. First, filter removes Goofy from the array. Then, for each loops through the remaining names, Donald and Mickey. For each of these names, it creates a new Azure storage account. This compact structure processes our list, excluding Goofy and setting up storage accounts for the other names in one operation. We can see that by using the full potential of TypeScript, we streamline our array using the filter method instead of conditional statements. Then, we iterate through the reduced array with for each. This approach is less error-prone, faster, and easier to debug. Now, let's have a look on the Python version 2. The key part of this Python code is the loop structure. This line combines a for loop with the filter function. Filter applies a lambda function to each name in storage account names, keeping only those that aren't a Goofy. The loop then iterates over these filtered names. For each name, which will be Donald and Mickey, it creates a new Azure storage account. This structure processes our list, excluding Goofy and setting up storage accounts for the other names in a single, readable line of Python code. As with the TypeScript example, we can see that we're leveraging the full potential that Python offers by filtering our list and then iterating over the remaining items. This approach is also less error-prone, faster, and easier to debug, just like in the TypeScript version. In today's session, we explored the distinct differences between managing loops in HCL and leveraging the flexibility of generic programming languages like TypeScript and Python with Pulumi. We saw how Pulumi allows for more intuitive, readable, and maintainable code by employing familiar programming constructs and streamlining complex operations. In our next video, we're diving into an even more advanced topic, for-each loops with multi-level nested dynamic blocks. Thanks for watching, and we'll see you in the next video.